Hello, ladies and gentlemen. I'm George from HiTarget. Today, we are going to talk about three basic functions of Hathaway with three parts. The part one is about ICO tools in detail survey page. How to make full use of the ICO tools in the detail survey page. And part two is about how to use quasi-dynamic survey. And part three, tier survey. Okay, let's talk about the ICO tools first. Most icons are shown on the left and the right toolbar. And there are two kinds of detailed survey value, graph value and test value. They can switch to each other easily. And look at the picture 4. For the meaning of each icon, just long press the icon, and there will show a small window to tell the function. Okay, go back to the icons. On the left toolbar, top 4 are zoom in, zoom out, zoom center, and zoom all. These are operations for map. Navigation means the software will switch to Google Maps to enter navigation mode. Attribute info means you can check attributes of each icons. Check attributes of each points, lines, and polygons. Control direction means the software will treat the control as the forwarding direction, not the receiver. Right toolbar includes different kinds of survey methods, such as intersection, average, auto survey, and a single stop point, and PPK collection. Hathaway also supports collect lines and polygons by culture create. Tier survey can be switched on and switched off. Here is a quick button. Of course, icons can be expanded and hide. So most of necessary and important icons are here. And generally, some icons are not often used and not needed. And the icons order is not good for the user, so they can edit, order, and delete the icon if they want. Also, they can reset it to the default. Icons not only can be used by screen touch, also can be used by control physical buttons. For example, users can press button 1 to zoom in map, and button 2 to zoom out map. The physical buttons also can be used for quick code. After defining the quick code of each button, physical button 1 to line can be used to store point with corresponding defined quick code. And this function will greatly improve work efficiency. Okay, one more thing. On detail server page, users can press the menu button to enter some often used functions directly, such as project setting, point library, raw data, and base and row setting. Okay, so much for this topic. There is poll for you. Please spare 1 minute to vote. 投票。拿坏了是吧？讲慢点。 投票1分钟还没结束。结束了，可以关闭，可以共享。Okay, seems like most people like screen touch and physical button both. Okay, thanks for your vote. Now let's talk about part 2, quasi-dynamic survey. Doing field survey in the heavy shadowed circumstance is a nightmare for surveyors because there will be so many problems. For example, receiver will get fewer satellites, more noise, more serious mounting pace, and the general signal is not stable. And also receiver will get low RTK fixed rate, more jump points. Accuracy is not stable. The coordinates is not correct, even if get RTK fix. As you see, the data quality between two circumstances, under shadowed circumstance, the satellite number is fewer and unstable. SNR and mounting pace looks terrible. Quasi-dynamic is using algorithms, which is developed by HiTarget, and it will provide a more stable and real-life artificial solution in the hard shadowed circumstance. The receiver is recording data stream from motherboard and doing quick PPK calculation, then combine PPK result with RTL results to reduce jump points. Quasi-dynamic is very easy to use, but firstly, you need to make sure your receiver supports it. Currently, V90 Plus, Arctic 5, V30 Plus support it. We suggest using the latest firmware, and you can download it from our website. Connect the receiver with HiSway. Quasi-dynamic can be enabled in additional setting page. And then the icon will be shown in right toolbar, but needs to let the receiver be getting RTK correction data for more than 13 seconds. And then quasi-dynamic is ready. Keep the receiver being strictly stationary and click the icon to start quasi-dynamic. And it will take 20 to 14 seconds to finish the initialization and collection. And there will be a ding dong voice from the receiver. That means the point is collected. Okay, let's see a video to know the whole operations.看你卡不卡？不卡。是看不了。投票。Okay, so much for this topic. There is a poll for you. Please spare 1 minute to vote. Okay. Okay, seems like most people want to test it first. Okay, thanks for your vote. Okay, next topic is about tier survey. Tier survey means the ground point still can be collected, even if the receiver is tilted. So how it works? Generally, the receiver gives coordinates of phase center. The tilt sensor gives tilt angle and the tilt azimuth. And it needs to know the distance from phase center to the ground point, of course. After getting all this information, Haswell will do the geometric job to work out the coordinates of ground point. By the way, tilt 2.0 no need tilt sensor. We will talk about it later. So in what kind of situation we need a tilt survey? For example, picture A. That point is very hard to collect, and it's hard to let the receiver be level. And the tilt survey will make it easier. Picture B. That situation needs you to get that point very fast, because there's so many cars, there's no time for leveling. And the picture C is impossible to let the receiver be leveling. And the picture D, the point in the under obstacle. So tier survey is very helpful for their situations. Currently, these receivers support tier survey, but they are with different kind of tier sensor. VLAN Plus and Arctic 5, the old mode Arctic 5, is with e-bubble plus magnetic sensor. This is the generation 1. Okay, let's talk about the first generation, e-bubble plus magnetic sensor. Before start the tier survey, the receiver needs to do calibration with 3 steps. The calibration needs a low magnetic interference and open air circumstance. And better do it in external working mode, because the internal USHF and the internal GSM has magnetic interference itself. And we suggest the battery is full charged and do not power off, or the calibration needs to do again. Step 1, electronic bubble calibration. Put the receiver on tripod and make it be perfect, levelly and stationary. Go to additional settings page to start calibration. About 3 seconds, it will be done, and it's very easy to success. Step 2, orientation sensor calibration. And this step will need more seconds and patience. Rotate the receiver 1 circle, just like picture A, and then rotate 45 degrees, like picture B, and repeat A and B about 8 times to finish. And step 3, magnetic calibration. Put the receiver on tripod and make it be perfect, leveling and stationary. And rotate the receiver with a constant and slowly speed. Better less than 20 degrees per second. Let us see a video to see how calibration clearly. This video is from our partner Adobe. 看我们看视频。我这边怎么卡住了？ Okay, thanks for the video. Thanks, Adobe. So generally, in what kind of situation need calibration? First, a new receiver and the first time using tier survey will need it. And change to a new survey air, the terrain and the circumstance changed too much and also need it. The calibration will be expired in 13 days and need to do it again. After the calibration, tier survey is ready to go. And tier survey has two methods. The first one, normal slope, is very easy to operation. And the second one, corner slope, and it can give more precise coordinates, but the operation is a little complex. About normal slope, just tilt and collect. It's fast and easy. But the accuracy is not good. It's not very good. So if you want to make a better accuracy, we can try corner slope. Corner slope will need to collect a point 2 times with 2 tilts at muse to give better accuracy. The horizontal accuracy can get 3 to 4 centimeters. Okay, let's see a video to see how it's working. Okay, thanks Adobe for the video. Okay, so much for the first generation. Let's talk about the next generation. Tier 2.0 is no need tier sensor. It's not magic. It's using real intersection. Tier 2.0 just need to keep shaking the pole, just like the right picture showing. It's like drawing a ball, and the collection will be finished after shaking 50 seconds. Okay, let's tell how it works. The distance from phase center to the ground point is constant, and it will not change during shaking the pole. Receiver will provide 5 Hz coordinates of phase center during shaking the pole. With these two information, hardware will work out the coordinates of ground points by real intersection. In other words, hardware knows the points on the ball and the radius of the ball, so the ball center can be worked out. It's just a geometric issue. The operation on software is not difficult. Just press the icon and then start shaking the pole. Generally, it needs 15 seconds to finish one point. Okay, let's see a video how to check the pole exactly. Yeah, it's about 15 seconds to finish that point. So how about the accuracy? If doing the right operation, the horizontal accuracy can get 5 centimeters. In open circumstance, just tilt 15 degrees and shake into a big circle, and it will get better accuracy. In shadowed circumstance, tilt 45 degrees and shake into a small circle, also can get better accuracy, because the receiver can face much sky and get more satellites. Okay, so much for tilt 2.0. There's a poll for you. Please spare 1 minute to vote. Okay, about 16% people already do their vote, and 80% people want to test it first. Okay, thanks for your time and their vote. So how about IMU? For now, the new mode, Article 5, supported. With IMU, tilt survey is resistant to magnetic interference, and it's no need calibration. And also it can get very good accuracy. The horizontal accuracy can do 2 centimeters. The operation on software is not difficult. But before start, the IMU sensor needs to do initialization with 3 easy steps. First, just get article fix, and then keep the receiver be leveling and stationary for a while. And then check the pole in one direction for a while. After that, tilt survey is ready to go. So let's see a video to see the whole procedure. Yeah, it's very easy to use. So how fast is IMU? Let's see a video to see how it's fast. Yeah, the efficiency will be greatly improved. I think every people will like it. So go back to all tier 7 methods. The first generation e-bubble plus magnetic sensor is needs 3-step calibration, and the horizontal accuracy can get 3 to 4 centimeter. The second generation, Tilt 2.0, is no need tilt sensor, just shaking the pole to do tilt survey, and the accuracy can get 5 centimeter. And the IMU sensor is no need calibration and is very fast. The accuracy can get 2 centimeter. Okay, so much for the tilt survey, ladies and gentlemen. Thanks for your time. So now it's Q&A time. Hello. Yeah. Hello, Antonis. Can you tell me the question?
Hello, George.
Hello.
Hello.
Hello, sir. Hello, sir. Yeah.
I have a question. I have a receiver V100. Does it support quasi-dynamic function?
Sorry, sir. V100 not support the quasi-dynamic. Only V13 Plus, Arctic 5, and V90 Plus support it.
Okay. Thank you. I take the number one.
Okay, thank you, sir. Thank you.
Hello.
Hello, Yano. Yeah. Hello.
Thank you for your presentation. For Tilt 2.0 survey can support V100.
Sorry, for now, only V13 Plus support it. V100
Okay.
not support.
Okay, thank you. I have one more questions. For the IRTK5 IMU survey, is it must to calibrate electric bubble is necessary?
No, Arctic 5 MU no need calibration.
But there is a okay. Thank you.
Yes. Thank you, Yano.
Hello, George.
Hello, Ellie.
How are you?
Yes.
Nice to hear from you. Not to take your time. I was having a question about the quasi-dynamic. You
Yes.
know, when you are under the trees, you are having a big chance that you don't have a fixed solution. Does quasi-dynamic works when you don't have fixed solution, or you should have fixed solution for it to work?
Generally, we suggest the receiver can be article fixed, but also article flows is also can do quasi-dynamic.
Okay, what would be the accuracy when it is in a float situation?
Generally, the quasi-dynamic is mainly improve the reliable of article fixed solution, and the accuracy can be 2 to 3 centimeter.
Yes. What about on the float? We don't know that, huh? We cannot. It's not reliable.
Yeah, it depends the circumstance and the correction data. Yes.
Okay. Thank you, George. Thank you.
Thank you, Ellie. Thank you.
Yeah, and thank you.
People ask a question. After turn of the Arctic 5 with MU, do I need to do initialization again after tone? Yes. Generally, after each restart, the Arctic 5 need to do the initialization again. Yes. Yeah, the correction status for the quasi-dynamic, no need article fix, float is okay. Okay, thank you for the questions. So much for today's webinar. Thank you.
We really appreciate your attendance and looking forward to meeting with you in our next webinar. Goodbye from High Target. Have a good day or have a good night.